All right, guys. So this uh, lecture is going to be to help you with the types of energy research assignment. Now, the initial goal of this assignment was for you to pick one of the 9 types of energy that I'm going to go over, do research for it, and then give a presentation to class, and then take notes on other people's presentations. But a number of people were absent on the day of the presentation, and so I'm just going to go through and do this as a lecture just so you can have the information. Okay, so looking over these slides, starting on slide 2 actually, we are going to define 2 different important terms. The first is called kinetic energy, and the second is potential energy. Okay. Kinetic energy is energy in motion. Okay. And there are 5 types of kinetic energy that we consider in this class. They are thermal energy, which is heat, mechanical energy, which is motion, electrical energy, which is electricity essentially, sound energy, and electromagnetic radiation. Which is light energy. Okay. Now each of these, when I say energy in motion, let's just kind of go over what that really means. So, for example, thermal energy or heat can be transferred from place to place. Think of like the source of heat in an instance and how that heat can travel from the source to something else. For example, the sun. Heat travels from the sun clear to the earth. It travels through space, right? Mechanical energy or motion is when an object is in motion. That's literally an object moving, and so therefore, of course, you could recognize the energy needed to do that. Electrical energy or electricity occurs because of the movement of electrons from one location to another through a system. Sound, it encompasses movement as well. You know, you have an origin, say me right now, and then sound travels. If someone was sitting in the room, they'd be able to travel to them. And then light or electromagnetic radiation also travels from its origin to other places. Once again, the sun is a great example of that. Potential energy, on the other hand, is not energy in motion. It's what we call stored energy. Okay, and it has 4 examples. These are gravitational, elastic, chemical, and nuclear. There we go. Okay, and each of these are an example of energy that could be used, that it's being stored, but it's not actually doing anything. Okay, gravitational is the potential to fall. It's the energy that could allow an object to fall. Elastic is the energy needed to return to its original shape. Okay, you can think of a rubber band that's pulled, and then that energy is not released until the rubber band is allowed to return to its original state. Okay, so we're going to go over each of these. I'm going to define them, give you examples, and then give you examples of what energy these could, under different circumstances, transform into. Okay, these won't be as pretty and probably not as fun as the actual presentations were in class. Students did a great job with the presentations, but this is just going to be a quick way for me to get this information to you and give you another study resource for the test. So the first one we're going to cover is thermal energy. Okay, as I mentioned earlier, thermal energy is heat. Okay, thermal energy or heat is dictated by movement or vibration, you could use that word as well, of particles. Okay, we've talked in this class before about how different phases or states of matter, their particles move a different amount. Solids being in one place but vibrating back and forth, where gases are very energetic and moving very quickly. And temperature is one of the main components that dictates what phase or state of matter something's in. Okay? Some examples would just include any source of heat. Okay, so you can say like the sun or an oven. Okay, or you're a source of thermal energy. Okay, and then transitions. Okay, let's look at a couple of these. So let's say we started with chemical energy, which can be found in our food. Chemical energy through digestion can be converted into thermal energy in our bodies. Like I said, you're a source of this energy, and then that thermal energy from your body could be used to become mechanical energy or motion, okay, as your body heats up the air that it's around it. Okay. As you heat up that air begins to move more and more energetically, and that's mechanical energy. Okay. Another example that I really like is the thermal energy from a fire can turn into electromagnetic radiation or light when it's radiation when you place a piece of metal in that fire for a long period of time. Eventually that metal will begin to heat up and could even begin to glow. Okay, hope that makes sense for you. Okay, another good moving on to our next energy, we're going to look at mechanical energy. Mechanical energy is the energy of an object in motion. I often say that mechanical energy is like the linchpin of all the different types of energy, where it's crucial and used for pretty much everything. And almost every transition will often have motion in some way involved. Okay, examples. Just think of anything that's moving. So let's say a car or your heart. Okay, just anything that's in motion is an example. Okay, transitions. Let's take, for instance, mechanical energy can convert into gravitational energy by something being lifted up, okay, which then can go back into mechanical energy when that object is released. Okay, another example could be nuclear energy, okay, which is the energy in, say, an atomic bomb. Atomic bomb would be our scenario here. And it could become mechanical energy in an explosion, right? An explosion occurs and just energy moves around like crazy, okay, as a release from that explosion. All right, so let's go ahead and move on to our next one, which is electrical energy. So electrical energy, here we go. Electrical energy. Electrical energy, as I mentioned earlier, is electricity. Okay, And it occurs because of the movement of electrons through a system. Okay. Some examples, just think of, electricity. Okay, electricity. So you could think of like a speaker or lights or things like that. Okay, anything that's going to use electricity is going to be an example. Transitions. Mechanical energy, which we just mentioned, is what generates electricity by turning a turbine. Okay, and that generates electricity. Or, sorry, I should say electrical energy. Okay, which then could turn into, let's say, sound in a speaker. Right? Okay, moving on, let's look at sound energy. Sound energy is when there is movement through a substance caused by a vibration. Okay, this can occur through gases, like sound normally does when we can hear it. It can occur through liquids. It can occur through solids. Okay, the keys are that it starts with a vibration, and that it travels through that medium. It doesn't just like stop in that isolated spot. It travels through it. Okay, examples, let's say clapping. So 2 P's, clapping. Okay, singing, right? Singing could be another example. Singing, or any source of sound, essentially. Okay, then transitions. So sound energy occurs because of a vibration. So a vibration is movement, which is mechanical energy, which transitions into sound through vibration. And then that sound, as it travels down your ear canal and to your eardrum, ends up creating vibrations again, or mechanical energy. Okay. Another experiment you can do is you can take something that has a real low resonation, like a bass drum, and you can hit that with a paper sitting next to it, and you'll actually see the paper begin to flutter. Okay. All right, moving on. Let's look at electromagnetic radiation. Okay. To put it as simple as possible, this is light. Okay. The key here, though, is that light is more complicated than you may know up to this point, because examples of light would include things like radio waves, like when you're listening to the radio in the car, or X-rays when you go to the doctor, or infrared, which is in your video games, and that sometimes you'll have like some sort of heat-seeking goggles or whatever. Maybe you've played a game like that. I did when I was younger, and you can see the heat that is emitted from somebody with those goggles. That's infrared light that you're sensing there. Some examples, you could just do some light sources as well, like the sun or a lamp. Okay. For transitions, what type of energy it was before, what kind of energy it became. we could start with nuclear energy, which is the energy that powers the sun, and that turns into electromagnetic radiation. Okay, and then that could convert into chemical energy via photosynthesis in a plant. Okay, or it could convert into electrical energy in a solar panel. Okay, all right. So that's the end of the kinetic energies. Let's move on to our potential energy. Okay, we're going to start with gravitational energy. So gravitational energy, as we've defined in class before, is the potential of an object to fall. Okay, examples. Think of things that could fall, like a car on top of a hill, or a skydiver in a plane. Okay, things like that. Those would be things that would have gravitational energy because they have the potential to fall. Okay, transitions. There's only one transition that can occur for gravitational energy. Gravitational energy always occurs because of mechanical energy, meaning that you can't gain gravitational energy without moving. Okay, we're going to say lift up. Okay, that goes to our gravitational, and then that can transition back into mechanical. As something falls. Okay, and that's really gravitational energy is that simple. That's the only transition that can occur. Okay. All right, moving on to elastic. Elastic energy, as once again we've defined this in class 2, is the potential of an object to return to its original shape. Okay, examples would be a spring, like in a trampoline or a mousetrap, or in the shocks of your car. You also have a rubber band, okay, or a bouncy ball, or all sorts of things. Okay, this one is also very simple. It always occurs because of mechanical energy. Okay, just say change shape. This could be stretching out a rubber band. This could be compressing a ball as it bounces, things like that. That forms our elastic energy. And then it releases back into mechanical energy as it returns to its shape. Return shape? Yeah, I like that. Okay. One thing that's different though with this than gravitational energy is we do also convert into thermal energy via friction. Okay, so it's not as much energy is conserved as with gravitational energy. Okay. 2 more. We're almost done. Next is chemical energy. Chemical energy is the energy found in chemical bonds, or in other words, the bonds between atoms, okay, in a molecule. Okay, the chemical bonds of a substance. And examples, we could have food, like we mentioned earlier. We could have wood. We could have explosives. Okay, coal, fossil fuels, all sorts of things like that. Okay, let's do a couple of transitions. Let's see. We mentioned earlier photosynthesis turning electromagnetic radiation into chemical energy. We also mentioned chemical energy becoming heat with metabolism or digestion, I should say. Mechanical energy could become electromagnetic radiation. With a fire, okay? All four of these are going to be with a fire. It could become heat or thermal energy with a fire. You could have motion with the fire I should write the technical term we're using here, which is mechanical energy. Okay? As the log burns up, it slowly will collapse and fall, and that's motion, right? And then sound as well, because as you have a fire, there's often popping sounds, that occur as well. So all of those would be chemical energy, converting into all four of those just in a fire alone, just in one situation. Okay? All right, let's do our last one. This is nuclear energy. Nuclear energy is very similar to chemical energy, where chemical energy is found in the bonds. This is the energy found in the nuclei, which is plural for nucleus, of atoms. Okay? Some examples of when we see this would be the sun. We see nuclear fusion in the sun, where smaller particles fuse together to become bigger particles. We have geothermal energy released by the earth. This is normally caused by nuclear fission, which is when big particles break apart to make smaller ones. You could also have nuclear power plants. You could have atomic bombs. Okay. You could also have medicines like chemotherapy use radiation from nuclear decay as well. Okay, transitions. Let's just look at nuclear energy being released through an atomic bomb. Okay, and this will produce light or electromagnetic radiation. This will produce heat as thermal energy. This will produce motion or mechanical energy. And even sound. So like I said, similar to your chemical energy in that way. All right. Hopefully this helped you with this assignment. Hopefully it's something you can use to help yourself study for the test. If you have any questions or concerns, feel free to shoot me an email, and I'm happy to try and help you out.